Welcome to Homework Walkthrough Video, Lesson 7.02c, Independent Practice, Experimental Probability. What? Question 1. A group of friends conduct an experiment of spinning a colored spinner shown 60 times. What a crazy experiment! They record the frequency of the spinner landing on each color. Red, blue, green, yellow, pink, purple. Cool. The table shows the frequency of landing on each color from the experiment. Complete the third column of the table by filling in the experimental probability for each color. Express each probability as a fraction or decimal only. Oh, so no percents. Cool, glad I read that. Fraction or decimal only. So, let's take a snip of this so we can draw. Draw. Okay. To find let me rewind. Theoretical probability is like, what's the chance of you spinning the spinner in the future? Experimental probability is what's the probability of it, of the thing that has already happened in the past. What was the probability based on your experiment? What was the probability? So, still kind of works. We still can make a fraction the same way, where we put desired outcomes on top of total outcomes, but it's not going to be 1 out of 6, 1 over 6. That's not what these are going to be necessarily. Let's see what they are. Desired outcome on top of total outcome. So we have, how many total spins were there? How many total spins were there? So we have 13 plus 11 plus 8 plus 10 plus 7 plus 11 equals 60. And it says that in the problem. It says 60 times. So 60 is going to be the total outcome for all of these. Every one of these is going to have a bottom number of 60. Over 60, over 60, over 60. Because the spinner was spun 60 times. All these colors are on the same spinner. Now for the color red, how many times was red spun? Oh, 13. So 13 out of 60. How many times was blue spun? 11 out of 60. How many times was green spun? It was spun 8 out of 60. Yellow was spun 10 out of 60. Pink was spun 7 out of 60. Purple was spun 11 out of 60. So here are our answers. Let's type these in. Click that check mark and type in my fraction over 60. 11. Oops. Gotta click that fraction button. 11 on top of 60. Fraction button. 8 on top of 60. 60. 10 on top of 60. 7 on top of 60. And 11 on top of 60, because 11 of the 60 spins were purple. This is the experimental probability. What happened after the experiment? What happened in the past? Let's check. Yay, 6 out of 6. All right, imagine you have a bag of 20 marbles of 5 different colors. So 20 total marbles, 5 different colors. 4 red marbles, 5 blue, 3 green, 6 yellow, 2 purple. Does that make 20? Yes, it does. You randomly draw one marble out of the bag without looking. The table shows the results of drawing a marble out of a marble out of a marble out of drawing a marble out of a marble out of the bag. Oh, okay. Oops. 60 times. So again, 60. Let's just make sure it says 60. 13 plus 14 times plus 11 times plus 15 times plus 7 times. Okay, good. 60. What is the experimental probability that a green marble being drawn out of the bag? So we're going to use, doesn't say to only use a fraction or decimal, so I'm going to put a percent here. Experimental probability is what happened in the past. Theoretical probability is what will happen in the future. What is the chance? What is the probability? What is the percent? What are the odds of you taking a green out? After you do the experiment, that's where you look at experimental probability. What actually happened? Did it match the theoretical? Did it match your chance? Because theoretically, we would have a 3 out of 20 chance. That's 15% chance. Theoretically, it would be 15. But let's see what actually happened with our experiment. So, take a snip of this, bring that over. So 11 out of 60, it's a little hard to see, 11, there we go. 11 out of 60 marbles were green. So I took a marble out. Oh, there's the color. Wrote it down, put it back in the bag. Every time I took a marble out, I put it back in the bag. 11 times it was green. What is this as a percent? 11 out of 60. Let's see. Oh, first, I can turn this fraction into a decimal by doing top number divided by bottom number. Then I can times that by 100 to turn it into a percent. Oh, 18.3%. So we talked a little bit. Theoretical probability. Theoretically, we only had a 15% chance because 3 out of 20 marbles were green. But after our experiment, we actually, 18% of the time, we got green, 18.3. 18.3 doesn't say to round, so I gotta add that repeating decimal bar by clicking on the arrow, clicking right there. Oh, there we go, 18.3%. Oops. Percent. There we go. Don't want that repeating decimal bar. It'll be a percent now. 18.3%. Okay, let's see if it marks it wrong. It did. Okay, so I'm going to put it in a fraction form instead. $11 out of 60. Way more simple, Mr. Bertram. Come on. There we go. Now we got it right. Imagine you have a 10-sided dice. Each of the 10 sides contains a number 1 through 10. You and a friend conduct an experiment by rolling the dice 164 times. What? And record the results of each number being rolled. The table shows the results. So 15 out of 164 times you rolled the number 1. 18 out of 164 times you rolled the number 5. 17 out of 164 rolls you rolled the number 9. So on and so on. What is the experimental probability you and your friend, what is the experimental probability of you and your friend rolling a 3 or 7? A 3 or 7. So that's theoretical probability is what happens before the experiment. So for each of these, like if you have a 10-sided dice, what is the theoretical probability of you rolling a 3? Oh, well, it's 1 out of 10, or a 10% chance of rolling any one of these numbers. That's the theoretical probability before the experiment happens. Experimental probability is where you look into the past after conducting an experiment. And experimental probability isn't always the same as theoretical probability. It's almost rarely the same. If we were to ask the same question with theoretical probability, it would be 20%. What's the chance of you rolling a 3 or a 7? Well, it's 2 of the 10 numbers, so that's a 20% chance. But let's see if it actually was a 20% chance. So the number 3 and the number 7. So out of 164 rolls, right? Yep, 164 total rolls, 16 of them were the number 3, and 15 out of 164 rolls were the number 7. So together, that means 31 rolls out of 164 total rolls were either a 3 or a 7. Now this is what I'm going to type into my answer box. But let's see if this is different than 20%, the theoretical probability. I'm going to turn this fraction into a decimal by doing the top number divided by the bottom number. Get a decimal, then I times that by 100. So 18.9-ish%. So we rolled, or whoever in the story, rolled 3 and 7 less often than what they predicted. Theoretical probability says that you should get a 3 and a 7 20% of the time, but we actually only got a 3 or 7 18.9% of the time. But let's type in this fraction as our answer, 31 on top of 164. Check. Yay! All right, if you need more help with this homework, let me know. I love to help. Good luck and goodbye.